We now discuss the solution of a problem from the section Integral Calculus that has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the second shift. The problem is related to the area of the given bounded region. The given question is the area of the bounded region enclosed by the curve y is equal to 3 minus modulus mod of x minus 1 by 2 minus mod of x plus 1, and the x-axis is, we are given four options. Option A, B, C, D. So we are given a curve. This is the curve, and we have to find the area of the bounded region enclosed by this curve and the x-axis. We now discuss the solution of the problem in detail. The given curve is y is equal to 3 minus modulus of x minus 1 by 2 minus x plus 1. Now it is clear that the values of y will change at x is equal to minus 1 and x is equal to 1 by 2. How they will change, we will see. We consider three parts of the bound of the domain. So we consider y when x less than minus 1 and minus 1 less than or equal to x less than half, that means between minus 1 and half, and x greater than or equal to 1 by 2. Thus three parts we have, and let's see how this y behaves. Now the first part, when x less than minus 1. When x less than minus 1, x plus 1 is negative. So send this minus 1 to this side, x plus 1 is negative. And not only that, and x minus 1 by 2, x is less than minus 1 by 2, and add minus 1 by 2 on both sides, then you will get x minus 1 by 2 is less than minus 1 less than minus 1 by 2 is equal to minus 3 by 2, which is less than 0. So that means both x plus 1 and x minus 1 by 2 are negative. Therefore, replace mod of x plus 1 by minus x plus 1 and replace x minus 1 by 2 by minus x minus 1 by 2. So, this is how it is replaced. Now, simplify and we will get it 2x plus 7 by 2. So, let's go to the second part. The second part is when minus 1 less than or equal to x less than 1 by 2. So minus 1 less than or equal to x means x plus 1 greater than or equal to 0. So that means x plus 1 is mod of x plus 1 will be just x plus 1 only, and x minus and x less than 1 by 2 is here, x minus 1 by 2 is negative, therefore replace mod of x minus 1 by 2 by minus of in brackets x minus 1 by 2. That way do it. Y is equal to this way. So then simplify, then you will get 3 by 2. Y is equal to 3 by 2. Now the third part, when x greater than or equal to 1 by 2. So x greater than or equal to 1 by 2 means x plus 1 will be greater than or equal to 1 by 2 plus 1, that is 3 by 2. 3 by 2 is greater than or equal to 0. Therefore x plus 1 greater than or equal to 0. And x greater than or equal to minus 1, x greater than or equal to 1 by 2 will imply x minus 1 by 2 is greater than or equal to 0. So both are positive. Therefore, replace mod of x plus 1 by just x plus 1 and replace x mod of x minus 1 by 2 by just x minus 1 by 2. So take the minus, take care of the minus. So be careful. So substitute and simplify, we will get minus 2x plus 5 by 2. Thus, we got the three branches of the curve, and we also have x-axis. And the curve, that is the region bounded by these three curves in these parts of the domain, and x-axis it forms a closed bounded region and required to find the area of the bounded region. So this is what we have done so far. So therefore y is equal to 2x plus 7 by 2 when x less than minus 1 by 2, and y is equal to 3 by 2 when minus 1 less than or equal to x less than 1 by 2, and y is equal to minus 2x plus 5 by 2 when x greater than or equal to 5 by 2. Agreed. Now how this curve will look like? So that's what our concern is. So first of all, let us see y is equal to 2x plus 7 by 2 when y is equal to 0. When y is equal to 0, that means where this part crosses x-axis, and the third part y is equal to minus 2x plus 5 by 2 and crosses x-axis. So that means for what values of x it will be 0. So y is 0 for what values of x. Now 2x plus 7 by 2 is 0 and minus 2x plus 5 by 2 is equal to 0. That means y is equal to 0 you are putting. That means you want to know where this curve crosses x-axis. So solving this one, you will get x is equal to minus 7 by 4. Solving this one, you will get x is equal to 5 by 4. So let's look at thus the curve intersects the x-axis at a point capital A with coordinates minus 7 by 4 comma 0 and at the point B with coordinates 5 by 4 comma 0. Let's look at the the curve. So x-axis, y-axis, and the curve meets the x-axis at minus 7 by 4 to 0, and more specifically y is equal to 2x plus 7 by 2 meets the x-axis at A, and y is equal to minus 2x plus 5 by 2 meets the x-axis at B with coordinates 5 by 4 comma 0. So and this A is due to the first part and this B is due to the third part. Agreed. Further, y is equal to 3 by 2. What is y is equal to 3 by 2? Y is equal to 3 by 2 is a straight line parallel to x-axis at a distance 3 by 2. So y is equal to 3 by 2 is this one, right? And it intersects y is equal to minus 2x plus 5 by 2. That is the third branch. The third branch means here. So this at C is equal to 1 by 2 comma 3 by 2. How do we get it? So y is equal to 3 by 2. Put y is equal to 3 by 2 in this. 3 by 2 is equal to minus 2x plus 5 by 2. Solve for x. Then you will get 1 by 2. So that is the C. And so also for the first branch. For the first branch, put y is equal to 3 by 2 in this. Solve for that. You will get another point. That is D. That is D with coordinates minus 1, 3 by 2. So the first branch will meet y is equal to 3 by 2 at D with coordinates minus 1 comma 3 by 2. Agreed. Now the bounded region enclosed by the curve and the x-axis. Say the bounded region is bounded by this and the x-axis. So that means this part it is shown in the field in the diagram. This is the shaded region. That is the bounded region, and whose area we are required to find. So that we will do in the next slide. Agreed. The bounded region enclosed by the curve and the x-axis is shown in this diagram and required to find the area of the diagram. And here we are not using that integral calculus, the integral of so and so. To do so, you have to break this into 3 parts and then 3 integrals you have to evaluate and then add. 3 definite integrals you have to do it and add. Instead of that, it is very easy. It is a most familiar curve, it's a trapezium, very familiar trapezium. This we have been studying from 7th class. So whose area we know. So it is a trapezium with the lengths of the parallel sides. What are the parallel sides? AB and CD. Why? Because this is x-axis and this is y is equal to 3 by 2. They are parallel. So AB. So what is the length of the AB? So the length of the AB, let us say small a, is equal to 5 by 4 minus of minus 7 by 4, that is plus 7 by 4, that is equal to 3. And so also CD, that is the other length of the parallel side. So CD is equal to B 1 by 2 minus of minus 1, that is plus 1, that is 3 by 2. And you know the height h is 3 by 2. So and height h is equal to 3 by 2, this is here. And now the area of the trapezium bounded by area of the bounded region, that is same as the area of the trapezium, is equal to very familiar formula, 1 by 2 into the sum of the lengths of the parallel sides, that is a plus b, into the height. Agreed. So now 1 by 2 into a 3 plus 3 by b 3 by 2 close into h 3 by 2, and simplify 1 by 2 into 9 by 2 into 3 by 2, and simplify, you will get 27 by 8. So that is the area of the given bounded region, and the answer is 27 by 8. And let's look at our options. Our answer 27 by 8 appears against option C. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of the problem which is related to the area of the given bounded region from the integral calculus. And the homework that I give it to you is that you find this area and get the same answer through integration. So, and my impression about this problem is that it is definitely an easy problem. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.